Morning SkyCiv team and other contestants. For this hackathon, I've built a quick and easy way to import hand-drawn bridges into SkyCiv. I call this application the SkyCiv Bridge Scanner. So for context, I'm still an undergraduate student studying computer science, but I have a keen interest for structural engineering and civil engineering as a whole. As such, I try to learn as much as I can in my spare time. I've learned multiple calculation methods, such as method of joints, method of sections, and a bit of finite element analysis. However, when practicing these, there are times when I'm doing questions and I get an answer incorrect, or I'm not even sure how to calculate a specific value. Because these are mostly textbook questions, I'm often forced to model the bridge by hand in SkyCiv and calculate the forces directly. Whilst this is fine for one or two bridges, after doing a lot of questions, this gets repetitive and it wastes a lot of time I could have just spent studying instead. Because of this, I've built this application that just takes an image of a bridge and it automatically exports it into the SkyCiv structural 3D tool, making the process of calculating bridges like this hassle-free and seamless. The application, at least, front-facing, is a very simple application. You upload an image of your bridge and you just wait for it to be processed. And once it's done, it's just automatically imported and rendered into the SkyCiv S3D application. So here's a quick demonstration of the application in work. As we can see, this is the image we want to get rendered. I'll just close that. Now if we press open, we can see that there's no file generated. Now if we go to our React app, we choose the file, which is our support one, and we press upload. It'll just take about 15 seconds to get processed to the SkyCiv API. But once that's done, it should be converted through our software into a bridge. And as it loads, and yes, perfect, it is loaded. As we can see, we have the bridge here, we have the supports, and we can see it rendered in 3D. So we've just done a one-to-one conversion of that image into a bridge using some image recognition. So how does it work? Firstly, bridges themselves are composed of three main components: nodes, supports, and the members connecting to these. Supports in this case also doubles as nodes. So what we firstly do is start with the nodes and the members via image processing by using a heuristic that deletes the lines under a specific thickness, after which we can use another model to identify the shape and detect if the item is a node or a support based off the shape. Once this is done, we can then also calculate the node's coordinates and then add this as part of the return data. On the other side, when calculating the members, we do the inverse. So basically we get the binarized image, we subtract the mask of all the nodes from it, just getting only the members. And once this is done, we can just calculate the endpoints of each member. And once this is done, we can just use a simple pathfinding algorithm to find the closest node to that specific member, and thus the index of each specific member, i.e. node 1 having member 1's start connection and node 2 having member 1's end connection. From that, we've now basically made the structure where we can just import it directly through the SkyCiv S3D API. We just basically pass all that data we've gathered through the image processing, and then we can just upload it as a SkyCiv file. The future. So yeah, that concludes my presentation. Thank you for listening. I believe this feature has a lot of promise and could save potentially hours of work for new and upcoming engineers, whilst also getting them interested in such software. In future directions, I believe we can increase the scope of the recognition model by firstly adding multiple support types, such as fixed supports, pin, vertical rollers, and so on. We can also additionally improve the detection accuracy by adding more pre-processing, making it better to detect hand-drawn images. And finally, we can also make this less of a black box. By showing more feedback, we can make it more clear to the user of what's actually getting recognized and what's not, allowing them to edit their image accordingly to get the best tracking possible. That concludes my pitch. Thank you for listening. Have a great one and good luck with yours.